Okay, last screencast we saw our first example of a market failure, which is essentially the free rider problem, and public goods, which is essentially the solution to that problem. In this screencast, we're going to talk about externalities, which are the second kind of market failure. And this is where really the bulk of the AP questions about market failures is going to come. So this screencast and the next one dealing with externalities, or maybe the most important screencasts of the unit. All right, so first a little bit of review. When I showed you a supply and demand curve for pretty much anything, those supply and demand curves were supposed to represent something. Demand is supposed to be a proxy or supposed to represent marginal benefit. So in other words, if someone's willing to pay like $12 for the 10th unit, which is what this demand curve is showing, what that means is that that 10th unit must be worth at least $12 to that person. That's the benefit they expect to receive from that good for that 10th unit. And that's why they're willing to pay $12 to get it. So every time you see a demand curve in these next couple of screencasts, I want you to think benefit, the utility that the consumer expects to receive from the good or service. When I showed you a supply curve, that supply curve is supposed to be a proxy for marginal cost. In fact, in perfect competition, we saw that the supply curve was essentially the marginal cost curve. So if someone's willing to sell that 10th unit for no less than $16, which is what this supply curve shows, it must have cost at least $16 to produce that unit, including a normal profit, because remember we include those in cost. That's the kind of cost. So every time that you see a supply curve in the next couple of screencasts, I want you to think the marginal cost, or the cost of producing that unit. So at equilibrium in a supply and demand graph, there was something magical about where supply and demand met. Not only was it where supply and demand met, but really it was where marginal benefit was equal to marginal cost. It was the perfect amount. This is the invisible hand idea. We called it allocative efficiency, the perfect right amount of stuff. Because at Q star we've produced every single unit where the marginal benefit was at least as much as the marginal cost, and we haven't produced any units where the marginal cost is greater than the marginal benefit. Alright, so that's where we've been so far. Now I want to discuss externalities. The definition of an externality is a cost or benefit incurred by someone who is external to a market transaction. Or alternatively, it's anything you do that also incidentally hurts or helps someone else. So when I go to the store to buy something, like let's say a cup of coffee, there are benefits that I'm expecting to receive from the coffee. There's a cost of purchasing the coffee. An externality is in any way that my purchasing coffee might affect other people, might impose a benefit or cost on other people. So for example, a lot of coffee plantations have really low-paid, low-skilled workers. Is it the case that by buying this cup of coffee, I'm supporting the exploitation of workers in some third world country? If that's the case, then my drinking this coffee and my buying the coffee involves a kind of externality. The word externality has the word external in it. It means that you're doing something that affects someone or something external to your transaction, to what you're doing. So here's a simple example one I used in the last screencast, buying gas for a car at a gas station. There are benefits involved. If I buy gas, I'll be able to drive my car. That's a benefit. I get utility from that. And there are costs involved. There's cost of producing gas. But there's also externalities involved. These externalities, in the course of production of gasoline, oil platforms blow up, and penguins, that's not a penguin, a pelican. Pelicans get covered with oil. That's an externality. It's an effect that my market transaction is having every time I go to the gas station, or one possible effect of that. So when you look at a supply and demand graph for something like gasoline, we have the benefits that the consumers receive, we have the costs of producing the gasoline, that's in the marginal cost curve, but what we don't have represented in this graph are the costs that are being imposed onto others, onto all the states that BP oil spill affected, on all the animals that were killed as a result of that BP oil spill. So the cost to the pelican, the water, the tourist industry, and everyone else affected by oil spills in the production of gasoline isn't represented in our supply and demand graph. So since that marginal cost curve isn't representative of really all the costs from the point of view of society, the cost to the pelican and the tourist industry and all of that, it's very unlikely that P star and Q star, which we were calling kind of magical before, it's unlikely that those are the correct Q star and P star from the point of view of society, because all of the costs aren't really represented in this graph. So we're going to talk about how we can start incorporating those costs and benefits and how we might re-achieve allocative efficiency, or really figure out what the right amount of gas is once we factor in all the costs and benefits. So we're going to start with negative externalities. These are sometimes called spillover costs. This is anything done that negatively affects other people. And what economic theory predicts is what a common sense human would predict. That if negative externalities are involved, we're going to do those things too much, what we might call over-allocation, from the point of view of society. So examples of negative externalities might be pollution, or playing loud music. You have certain costs and benefits of playing loud music. That loud music might annoy other people. That's an externality. Or something like secondhand smoke. If you're a smoker, there are benefits of smoking and there's costs of smoking, but there are also costs that you impose onto other people when you smoke. Secondhand smoke has health effects that might hurt other people. That's a negative externality. Alright, so we're going to try to incorporate these externalities graphically. So I'll use as an example the market for cigarettes. The demand curve represents the benefit people expect to receive from various quantities of cigarettes. The supply curve represents the costs of producing various quantities of cigarettes. P star and Q star might represent the price and quantity of cigarettes bought and sold in this particular market. Now remember, the demand curve represents the private marginal benefits from smoking. It's from the smoker's point of view. And the supply curve represents the private marginal costs of producing cigarettes. That supply curve and the costs involved are from the producer's point of view. Marlboro, R.J. Reynolds, the other cigarette companies. So for example, the marginal cost of producing the second pack of cigarettes might be $4. But what isn't represented in this graph is this kid and all the other kids that are negatively affected by secondhand smoke. Let's say that each pack of cigarettes imposes $1 worth of health costs onto others. $1 more of asthma or emphysema or other kinds of health costs. There's the phone. I gotta get that. I'll be right back. Alright, sorry about that. That was nonsense. Alright, so if cigarettes impose $1 worth of health costs onto others, then the societal marginal cost, which you can think of as the marginal cost to the producer plus the cost imposed on others. In other words, the total cost involved of cigarettes would now be $1 higher for each unit produced. The societal marginal cost of that second pack of cigarettes wouldn't be just the $4 to produce the cigarettes. It would now be the $4 to produce the cigarettes plus the $1 worth of health costs that we're imposing onto others in the form of worse health outcomes. And of course, the cost of every other unit is also going to be $1 higher. Meaning that the true societal marginal cost curve, the private costs, the red line, plus the externality, the spillover costs, is going to look like this, the blue line. It's essentially the red line shifted up by $1, that $1 worth of negative externality, that $1 worth of extra costs that we're imposing onto other people. So we're going to distinguish between private marginal costs here, the cost of producing the cigarette, and societal costs, the private costs plus the cost imposed onto others. In other words, the cost to the kids and the cost to the producers, all the real costs involved. Now the old P star and Q star seemed to be allocatively efficient before we started thinking about other people, but they really weren't. Before, we were over-allocated. The truly allocatively efficient P star and Q star would instead be here, at the blue P star and Q star. That's where the real marginal benefits are equal to the real marginal costs, all the marginal costs. So from the point of view of society, considering all of the costs involved, there should really be less cigarettes bought and sold. You could see that we were over-allocated, and the new quantity represents the societally optimal quantity of cigarettes, which is less than what we had before. Again, the moral of the story is that when there's a negative externality involved, we tend to do those things too much from the point of view of society, and we should do them less, which just makes sense. When you're hurting other people, we're probably doing those things too much. All right, so let's talk about positive externalities, what are sometimes called spillover benefits. This is anything that's done that positively affects other people, and economic theory predicts what common sense would predict. That when we're talking about nice things that we do or things that positively affect other people, that from the point of view of society, we'll tend to do those things not enough. In other words, we'll tend to under-allocate. So an example of that might be vaccination. If you get a measles vaccination when you're a baby, you're helping yourself, but you're also helping other people. There's a positive externality involved because you're less likely to spread measles to other people. Education has a positive externality. If you get a good education, not only are you likely to pay more taxes, make more money and pay more taxes later in life, which will help me, you're also much less likely to rob my house later in life. That's a positive externality, something that you're doing that might positively affect me. Or take something like anti-lock brakes. Maybe you're thinking about buying a car and you can choose whether or not to have anti-lock brakes. Well, buying them would have a positive externality because if you buy those anti-lock brakes, I'm less likely to get into a terrible, fatal car accident. You're less likely to hit me. Positive externality. All right, so let's use the market for anti-lock brakes as an example of a positive externality and see what that looks like graphically. Again, the supply curve represents the private marginal costs of producing anti-lock brakes. The demand curve represents the private marginal benefits from anti-lock brakes. I might buy anti-lock brakes because they give me a benefit. I'm less likely to get into a car accident. So for example, the marginal benefit of producing the second unit might be $90. Someone might be willing to pay up to $90 for that second unit of anti-lock brakes, meaning that they expect to receive at least $90 in benefit from those anti-lock brakes. But what we haven't considered in this graph is this guy, the guy your car just hit. Let's say that each anti-lock braking system, or ABS, saves $10 in repair costs by reducing the severity of accidents. That's essentially saying that if I buy anti-lock brakes, I'm going to benefit somebody else by the amount of $10. So the societal marginal benefit, the marginal benefit to the consumer plus the benefit given to others, would now be $10 higher for each unit sold. The marginal benefit of that second unit wouldn't be 90 anymore. The societal marginal benefit would be the benefit received by the consumer, 90, plus the benefit showered onto others, that $10 worth of benefit. And again, that's going to be true for every single unit sold. Every single unit sold is going to have a benefit $10 higher than what the consumers see. Meaning that the true societal marginal benefit curve, the private benefits, the red line, plus those spillover benefits, is going to look like this blue line, which is essentially the red line shifted up by $10, those $10 in spillover benefits. Again, that old P star and Q star seemed to be allocatively efficient when we weren't thinking about other people. That was the right amount from the point of view of society, but we weren't considering the fact that there were spillover benefits involved. Once we factor those benefits in, we could see that we were under-allocated before. We weren't producing enough anti-lock brake systems from the point of view of society. The truly allocatively efficient P star and Q star would instead be at the blue P star and Q star. So from the point of view of society, there should be more anti-lock brake systems bought and sold. All right, so we've seen what positive and negative externalities look like graphically. In the next screencast, we're going to talk about how we might solve these positive and negative externality problems, how we might move from the seemingly allocatively efficient P star and Q star to the truly allocatively efficient P star and Q star.